In this step of setting up the recast framework, we're going to encode the first step of the analysis workflow, so the event selection step, in our specs./steps.yaml file. So to do that, I'm going to go over to our GitLab project and open up the steps.yaml file. And we're going to go through and modify this Hello World framework that we're starting with so that it's instead encoding this first event selection skimming step in our workflow. So the first thing I'll do is rename the step to event selection. And then the next thing that we can do right off the bat is update the image to the image that the Dockers that we created for our event selection GitLab project using GitLab CI. So I'll go into the GitLab project for our event selection code. And you can go into the container registry. And click on the clipboard next to the latest image tag to copy the full Docker path to the image and paste that in here. Now in this case, we actually want to specify the image and the image tag separately. So I'll just copy the image tag and get rid of it here and paste it into this image tag field. So now we've got our environment set up, and the next thing that we need to do is just update what actually gets run inside the Docker container to execute our event selection. So I'll go into the README and just see what needs to be done. So the first thing that needs to be done is to compile the executable, but we've actually already done that when we set up the Docker image. So remember, we had this line that built the event selection executable. So we should actually already have access to that executable. And then the next step is to actually run the event selection on an input T-tree with our signal MC and produce a skimmed output T-tree. So I'll just copy that command into the script field. Now, I just want to go through the code quickly so you have an idea of what's going on in the selection. So the code is reading in the path to the input unskimmed signal T-tree. And then it's also reading in the path to the output skimmed T-tree. And it's also reading in the maximum number of events to run over in the input T-tree. So if you just want to like test on a small subset of events, you can do that by using this max events parameter. So the next thing it's doing is just setting up the pointers to the branches for the branches in the input and output T-trees. And what these are the mass of, so this MJ, which is the mass of the leading large radius jet. And then this met significance is the other branch in the input T-tree. Now, if we supply the max events as -1, then the code interprets that as us saying that we want to run over all of the events in the input T-tree. So we can use -1 to specify that. And then what it's doing is it's going through the events in the input T-tree up to the specified maximum number of events. And for each event, it's applying a lower bound of 16 on the met significance. And if the event passes that cut, then it's the branches get written out to the output T-tree. And then, yeah, that it goes through all of the events and makes that selection. So as you can see, this is a relatively simple selection, but it's just meant to represent the kind of skimming that we might want to do on an input file. Okay, so I'm going to set the maximum events to run over to 100 just for testing. And then in this case, the output T-tree is actually going to be a variable because it's going to get output by this step and then read in by the next step that actually does the statistical analysis. And the way that we specify this as a variable is using these curly brackets. So yeah, the Yadage engine will interpret anything inside curly brackets as a variable. And Yadage is the actual workflow specification language and execution engine that this Recast Atlas client is acting as a wrapper for. So I'll call this output file. And in this case, we can actually give the input file a name because we're going to be copying it into the Docker container from EOS. So I'll call it signal.root. Okay, now the next thing that we want to do is actually copy this input signal.root file in from EOS. And the way that we're going to do that is, first of all, by setting up the authentication. So if we go over to the Recast docs, there's a section that explains how to set up this authentication. So it's this authentication section here. And the first thing that we can do is add a resource grid proxy to our environment. Oops. And this extra resource is telling the Recast Atlas client to mount this this auth dir that we created when we initially set up our authentication into the Docker container. Oops. So yeah, so that should be set up. And then the next thing that we need to do is run this get. Oops. There's this get KRB script. So the script is actually doing the Kerberos kinit with the credentials that we supplied to this auth dir directory when we set up the authentication initially. So that should take care of Kerberos authentication. And now we can actually do the copying. So before we do any copying using xrootd, we have to set up the Atlas analysis software by sourcing the release setup script in the Athanalysis image. And then we can use xrootd to copy the signal file into the Docker container using xrdcp. And I'll call it signal file. Okay. And then we want to copy it into the signal.root file that the event selection reads in. Now, this signal file variable is going to get supplied to the workflow, and it'll be an xrootd path to the signal file where it's actually being stored in our dedicated directory in the central recast project area on EOS. And the last thing that I'm going to do is just rename the published variable to something a bit more specific. So I'll call it skimmed signal. Okay, so that should be everything that we need to run our event selection in our preserved analysis Docker image. So the next thing that we're going to do in the subsequent video is set up a unit test in our recast.yaml file to test this event selection in isolation by providing the input signal file and just make sure that everything is working as expected.